Hi, welcome to Jude's tutorial video on calculating speed on motion graphs. I'd like to tell you a little story before we begin. Celia walked at a constant speed from her house to the grocery store. She then stayed at rest while she was checking her grocery list. Then she realized that there wasn't any time left, so she ran at a constant speed to go get her grocery items. Before we begin all of this stuff, I would like to tell you about a little pyramid. So you have the D on top, the S to the left, and the T to the right. Then you would put a division sign here, a division sign here, and a multiplication sign right here. The D stands for distance, the S stands for speed, and the T stands for time. Say, for instance, that you had a distance time graph. Obviously, the only thing that they give you is distance and time. You then need to figure out the only thing that's left, which is speed. You would then put your hand on the S and see what's left, the D and the T, or distance and time. Then you would look at the operation that is left. So it would be distance divided by time. So you have right here, speed equals distance divided by time. Say you wanted to find the distance. You would do the same thing. So it only gave you a speed time graph. So you would put your hand on the D for distance, and you would do speed times time. Distance equals speed times time. Then, if you wanted to find time, you would put your hand on time, look at the two that are left, and the operation sign. So it would be distance divided by speed. Time equals distance divided by speed. Back to our story. Let's say, as we said before, that she was at a constant speed from her house to the grocery store. That kind of looks like this, doesn't it? This is time, this is time, this is distance, this is distance. Perfect match. Now, notice how I said moving at a constant speed. That was correct. But on a speed time, it looks like this. The reason it looks like this is because it says constant speed. And as you can see right here, the speed is constant. Right here, if you were to do what we were teaching you, to find the speed, you would divide distance into time, and it would come up with the constant speed. Now, she was at rest, or no motion, as she was looking at her grocery list. That is down here. Perfect match. You have time, time, distance, distance. As I said, no motion, which stopped or is at rest. This is how it would look on a speed time graph. If it stopped or at rest, you wouldn't have very much of a speed, which is why it is kind of flatlined right here. Make sure when you do this, it doesn't look like this or like this. Make sure it always looks like this, touching the bottom, or else it would be counted as this, wouldn't it? And then of course right here, she was at a constant speed once again, which is the same right here. As you can see, we have our distance time right here. We have our constant, which is what we talked about, and our constant for speed time, constant for distance time, which are two very different things. Then we have slowing down, or deceleration, which looks like a very sad face right here on a distance time. As for right here, you have slowing down, which means you're decreasing your speed. You have speed right here, and of course it is decreasing. Then right here, you have acceleration, or speeding up. So as you can see, as for this one was sad face, this one is a happy face. That's something you might want to remember if you want to memorize the sad from the happy. It would help you memorize a lot better with what you have. Then right here, acceleration looks like this because your speed, unlike this one, is increasing instead of decreasing. And then we have no motion, or at rest. So as we talked about right here, your distance stays constant. Right here, your speed stays constant. Or your speed has nothing at all. And if you were to divide this into this, your speed would also have nothing at all. Then we have one right here, if you can see it, and it's called back to start. So it's a distance and time, and it has a point. So it's starting from the very top on your distance all the way down to your time. Now, if we wanted to find the average speed for the entire trip, which is from A all the way to D, which is the entire trip, this is what you would do. So, you would have if you wanted to find the speed, which is your keyword, you would do speed equals distance divided by time. Now, if you wanted to find it for the entire trip, you would start at the highest point, which is D. Then you would do since it says distance divided by time, we would find its distance first. And its distance right here is 100. So let's write in 100. Then you would continue this line and write down its time. If you would draw this down, it goes down to 50. So you would write down 50. So for the entire trip, all you really need to do is divide 50 into 100, and you would get 2. Now, you can't just leave a naked number, 2, because what is it? 2 pizzas, 2 girls, 2 boys? So, in order to find what the unit is, you would see what your time is in seconds, and see what your distance is in miles. So it would be 2 miles, or 2 meters per second. 2 miles per second is not really human. Let's move on to this next question. What was the average speed for segment C through D? So you have C right here and you have D right here. And if you want to find the average speed between them, this is what you do. Once again, you are looking for speed. So you would do your speed equals distance divided by time rule. Now, as we already have right here, we have to find our highest point, which is already the D, which is 150. Then you do subtraction. And let's find the distance for C, which would be 40, which would be 40 minus 40. Continue the line. And then right here, in the middle of 40 and 60, which is 50, minus 50. Now, 100 minus 40 is 60. Oh, no, this is not 50. Well, hold on. No, this is 30. Yes. So, 50 minus 30 is 20. And then this equals that. And you only have to continue the line. So, this line right here means that you have to divide. So divide 60 into 20, what is this? Yes, 20 into 60, and it equals 3 miles per second. Okay, so now that you have understood the different types of charts, and you understand how to calculate speed, distance, and time, and you know how to calculate average speed for different segments as C through D by getting the tallest one, its distance and its time, because you are doing speed equals distance times divided by time. So you'd find its highest points, and you subtract them with its second segment, which is this lower one. You would get your answer, and then you would divide. Now, one more thing before we go. As we talked about right here, this graph would look a lot different if it was on a speed time graph. It would look like, so this was your constant, and if you look back here, your constant is a line. So let's write a line. Then you're going into rest, and this is your rest. So you do a line straight down into your rest. Then you would do a line up because you're doing constant again. Here's your line up. I hope you enjoyed this tutorial, and now you learn a much better understanding about how to calculate speed or distance or time on a motion graph. I hope you enjoyed my story.